Section 20.8, circuits wired partially in series and partially in parallel. So at this point, we've seen circuits that are purely series, purely parallel. What about when we bring them together? We can get something that looks like this circuit here, right? Where some of this is in series, some of it's in parallel, and it seems like a mess. How can we possibly untangle this? Well, there's a rule that I came up with, and that's that parallel circuits are like parentheses. You must first simplify everything inside the parallel circuit, and then you can combine the parallel devices. So as we look at this circuit coming out of the 24-volt battery, it passes through one resistor in series with the battery, and then there's this junction at A where it's a parallel circuit. It can go down through the 180 ohm resistor, or it can go to the right through these other two, and at B they join back together. So these other two are complicating our parallel circuit. So we need to first combine these. And we notice the 220 ohm and the 250 ohm resistor are in series. Once you're on this outer branch, you have to go through both of them. So we can find the equivalent resistance of both of these since they are in series by adding them together. So 220 plus 250. So we'd find that that is 470 ohms. So we can then redraw our circuit, and instead of having two resistors there, we can just have them as the single 470 ohm resistance. Awesome, our circuit is already looking better. What's our next step? Well, now that we've simplified everything inside, we can now move on to the other one of combining the parallel devices. So the parallel devices are the 180 ohms plus the 470 ohms, right? These two are wired in parallel. They're the next most complicated thing to take on. So if things are wired in parallel, we remember our equation is 1 over Rp is equal to 1 over 180 plus 1 over 470. And this is where I'm not going to try and do those fractions, right? I'm going to use a calculator. So when I calculate this out, I get 0.00768. But it's not in units of ohms yet, right? Because the ohms are in the denominator. So it's in 1 over ohms. If I want to get it as my resistance, I need to take the inverse of it. So I need to take this and inverse it, and then also inverse the other side. We can't just inverse these fractions because we need to add them first. So that's why we get to this long decimal point. But since I still have it in my calculator, all that I have to do is hit the inverse button, and it'll inverse it for me. And then it comes out to a number that's much more reasonable. It tells me that Rp, now that I've inversed it, is equal to 130. And ohms is now in the denominator, as it should be. So we can write these two resistors in parallel as a simpler 130 ohm resistor there. And I encourage you to take the time to draw out each step of the circuit. It makes it so much easier to solve when you do that. Okay, so we've now combined our parallel devices. What's left to do? Well, let's look at what's left. And sorry, I wrote over that part of it. So let's make the picture down here. So once all the parallel circuits are simplified, combine the remaining series devices. So all that we have left are the 110 ohm and the 130 ohm resistors that we had. And these are in series. There's only one possible path through them. So how do we combine resistors in series? We just add them together. So if we add those together, 110 plus 130, that should come out to 240 ohms. So sure enough, it comes out to 240 ohms. That is the equivalent resistance of the entire circuit, which you could abbreviate as R sub EQ for the equivalent resistance. And once you know the equivalent resistance of the circuit, you're able to find the total current very quickly because you know the total voltage and the total resistance. So the current will just be 24 volts divided by 240 ohms. So it comes out to, I believe, 0.1 amps. And that then allows you to figure out the power and any number of other things. So this was a brief overview of how you can approach circuits that are a more complicated combination of both being wired in series and in parallel.